Hello students, already we have discussed module number 1 regarding introduction to metal forming as well as module number 2 regarding forging. Moving on to the 5th module, the topic known is high energy rate forming. So here in simple words, it is also a forming process itself where we are using energy, of large amount within a small amount of time, which means huge quantity of energy is used to develop the metal forming process within a specified short interval of time. Why we are using this one? Because already we have discussed the metal forming process. It is also a type of a production process where particular components we are developing them using the forming process itself, that is by melting them to the above recrystallization temperature or below recrystallization temperature to develop the desired product. In that itself, there is a smaller section known as high energy rate forming, which you can see on the screen. So if you observe here regarding in the high energy rate forming, in very simple words, what we can say that we are taking use of the energy developed by different means to develop the desired shape and size of the product within a short interval of time. And this we are using especially when we want to develop the parts and products in a large quantity, which you can say that is a batch production at a less amount of time, such that we call this process as high velocity forming processes. When you are developing the products in the batch wise size, then the dies which you are using them almost they are the same dies itself, which means the production of die cost is lesser when compared to the other metal forming processes. That is, it may be compared to the forging, drawing, or the bending. Here the die cost in this HERF process is cheaper in nature, and when you are applying the huge amount of energy for the forming process, then automatically even the tolerance limit is lesser, which means there is less maintenance, and you can develop the required materials which does not show any spring back effect. So using this method, you can develop large number of components within less amount of time, and also along with that the production cost of these components by this process, it is cheaper in nature, which you can say that is economical. But the only important thing is the person who is working on this high energy rate forming, you should have a good knowledge regarding the dies design, the type of energy developed, as well as you should be skilled in all the basics of the processes involved, which means you need a skilled personnel. Then what is the principle behind this one? So the principle behind this one is just you have to develop energy. The energy developed will be so much that you should be able to deform the workpiece of a given material. Different materials are there, already you know. We are using different materials for different applications such as aluminum, copper, iron, steel, brass, many more materials. So depending upon the materials, we are applying the type of forces also, that is the energy required. So whatever the energy is developed here, it should be so much high that it should be able to deform the required workpiece at a higher rate as told within less amount of time. The conventional practice is nothing but, already we have studied in the forging chapter, that with the help of the ram with various applications, that is using the hydraulic energy, pneumatics, or any other energies, we are applying the force on the ram which is responsible for developing the desired product. But here, instead of that, we are directly applying the energy for the workpiece itself. So when the energy is applied, what happens? The particles present in this energy, they are traveling with the greater velocities, which are responsible to develop the forming process, and they are compared with the conventional forming process also. Therefore, when the velocity of deformation is in this case, especially for the high energy rate forming, it is very larger in nature, and that is the reason that we call this one also as high velocity forming processes also. Here also already we have stated that whenever the material is being deformed within the elastic limit or beyond the elastic limit, it leads, when it goes beyond the elastic limit, it leads to the fracture, and that fracture depends upon the working material range, depends upon the type of the metal, and it leads to a critical strain rate also. So whereas in this type of process, you can observe here the elongation to the fracture, it also increases along with the strain rate applied on that material. Automatically it ruptures when the ductility point drops at a particular point. Apart from this, if you observe here, in this case also, already we have discussed that the stress is always proportional to strain within the elastic limit, that is our Hooke's law. And once it jumps beyond the elastic limit, it goes to a plastic state of deformation, which is nothing but the ultimate definition of our metal forming subject itself. So here also, if you observe, here a strain rate depends upon what? Regarding the strength increasing itself. So as how does this strength increase? It increases with the increasing temperature. That is the reason that we are learning regarding topics known as cold forging as well as hot forging also. So when the metal is being heated within the plastic limit or beyond the plastic limit, it undergoes a strain deformation. That depends upon what? Regarding this temperature factor itself. Then already we have discussed these points regarding the yield stress and flow stress in the module number 1. The same two parameters, they come into act where during the plastic strains, and which they depend upon what? Regarding the strain rate applied at the tensile strength itself. So when this yield stress and flow stress are coming into existence, there is a dependency on the high rates of strain. This is responsible to cause the yield point to appear for adjusts for low carbon steel, which does not show any yield point under ordinary rates of strain. So these are the principles of HERF process. But the main important thing what I would like to say is we are applying the energy within a less amount of time for the deformation process, and they are moving with high particle velocities known as high velocity forming processes, and it is almost equal to the same of the deformation rate when compared to the other metal forming processes also, but it is a most effective one. Then we can't go for a high energy rate forming directly itself. We need to choose some of the factors before we go for the selection of this process. What are the factors required? So if you observe here, one important thing given is the size of the workpiece. So what it means here is, especially if we go for the applications or building the body parts of an aircraft or some ship body parts or larger body structures whose size is very large, where you want to develop some curved shaped structures such as boiler vessels and all, you cannot go on doing on a simple methods itself. At that time, we are depending upon the size of the workpiece, what is the geometry of deformation, at which particular points you want to apply the load, and which type of work material you are preferring such that it should withstand high strain rates. That is, if you take the example of a boiler vessel or the aircraft's body structure or the rockets, they have to withstand high restraint rates along with the higher temperatures when they are moving the space. Then for this deformation, here we are not using the force, but instead of that we are using the energy requirements. So how much is the energy required, that you have to calculate, and whatever the energy is required, how we should develop this energy, or from where the energy has to be transferred. Then with respect to this is the very important thing regarding the designing of the die, placement of the die, and to see that what is the cost of the die and for how much times you can experiment with them, and including all this, what is the budget, or you can say that overall capital investment of this particular system. So more or less around 6 to 7 parameters you need to know for the working of an HERF process. Now for your syllabus, you need to know there are 3 types of HERF processes. The first one is explosive forming, second one is electro-hydraulic forming, and third one is electromagnetic forming. So if you go for the discussion of the first topic, that is an explosive forming, the name itself says here there is some explosion done with the help of, you can say, any explosive material such as the TNT, that is the trinitrotoluene, RDX, dynamites, or using some explosion gaseous mixtures or propellants such a way that by a sudden explosion large amount of energy can be developed. It is so much high that it is responsible for applying the force on the workpiece to get deformed to the desired shape and size, which means the energy developed is so much high that it gets the deformation within less amount of time with a good perfect design. So this is the first one, that is the explosive forming. So this you can see in the picture. We are using two images here. And one more important thing is, in the explosive forming you are using of two things, two types. One is the first type known as standoff technique, or you can also call it as unconfined technique. What is this standoff technique? If you observe here in the figure, this is the setup. This blue colored, it is the workpiece. It is clamped to the two clamps hinges here. Then you can see this is the die cavity. You can see here, this is it is like a dome shaped, curved shaped structure. It is a die cavity. At the bottom there is where they have provided a provision for taking out the air from this die with the help of a vacuum pump. Then you can see this entire assembly where it is placed inside the water, and from this workpiece at some distance, there is some distance you can see here. This distance we call it as standoff distance. Keep this in mind. For the explosive forming using standoff technique, which it means the explosive material which you are seeing here, this red colored material, it is not in contact with the workpiece directly. It is at some distance away from the workpiece. We call it as the standoff distance. So this is the entire setup developed, and you can see we are placing the water inside this entire setup. The reason is simple. Once the explosion is done, a huge amount of pressure energy is created inside the water, or you can say that a pulse energy of a speed of around 120 meters per second. It is so much high that you can see here in the side figure, whatever this workpiece is there, it gets deformed to the desired die shape, and this energy is transferred through the water itself. Why we are using water is, it puts uniform amount of pressure over the entire workpiece, which means deformation becomes uniform. First important thing. Second important thing, due to explosion, large amount of sound can also be developed, which means it is a noise pollution that can be avoided when we are placing this in a water. Therefore, the explosion is done inside the water itself. Before explosion, if there is any air present here inside the die cavity, it is taken off with the help of a vacuum pump, such that once the material deformation occurs, you should see that there is no defects in this entire workpiece. So if you observe, this shape is nothing but it is the nose of a rocket or an aeroplane, this dome shaped structure. Similarly, we are using in the ships also. So especially when you want to develop some curved parts, especially for the satellites or dishes, we are using this type of application itself, where you can develop in a large quantity and you will get developed within a less amount of time. So the things I was explaining you, what is the purpose of using the water here is, it is a medium through which the energy is transferred, as already told you, and in the water, whatever the energy is developed due to explosion, it is acting uniformly over this entire workpiece. That is the reason that the deformation takes place uniformly, and any point if you check, you will get the correct values of the safetiness itself. Also, it prevents the sound explosion, and he says regarding the cushioning effect is good for this one without any direct contact. Suppose if you place this explosive material directly in contact with this workpiece material, there are chances that sometimes it may lead to the damage of the center workpiece along with the die cavity also. And especially it is used for some kind of metals where they can be developed with a good design, keeping the explosive material at some distance away from the workpiece. So already I told you what are the process variables regarding the type of explosive which you want to choose for which kind of material. Very important thing is this of standoff distance. So some metals require huge amount of energy, some metals require a less amount of energy. So depending upon the amount of energy developed, you should decide how much amount at what particular distance you should place the explosive material away from the workpiece to get a perfect design. And generally many times we are using water as a correct working medium so that the energy can be transferred uniformly throughout the entire workpiece. And the more important thing is removing the vacuum from the die. This is the things regarding the first type of forming, explosive forming. So some of the advantages what you can say here is, as I told you, once the shock wave is generated, it is transmitted through the water. As I told you, it does effectiveness, it's good work on the workpiece. As it is placed in the water, there is less noise, and the chances of the damage to the workpiece is also very less. This we are especially using when the metal parts which you are using, especially if they are larger and thicker parts, you can go for deformation using this process. So when you compare to the screws and process which you already learned in module number 2 of the forging section, this is an economical part. Only thing, the costlier thing here, if you observe here, is the explosive material itself. Other than that, things are very easily available to you regarding the water and preparing the die also. But the limitations, there are also some limitations. What are the limitations? I told you, for each kind of workpiece material, the standoff distance is not the same. It may vary depending upon the type of the work material and the type of how much amount of energy you want to develop. Therefore, you should know what is the optimum standoff distance. SOD means optimum standoff distance responsible for proper forming operation. Then you should remove the vacuum. If there is any vacuum, then automatically it leads to the failure of your workpiece. It will not develop a good surface finish. And the dies which you are using here, they should be larger in size, and they should be so much stronger in nature or thicker in nature that they should withstand the shocks produced. Otherwise, it may lead to the damage of the die cavity also. If the die is damaged, automatically even the workpiece metal also gets damaged. So this we are using only for thicker shapes, which means you cannot use small or thin cross-section materials. And the explosives which you are using, you should use them very carefully with the safety conditions. This is regarding the explosive forming using standoff method. The explosive forming, another method I told you regarding the contact method, or is the confined method. So here also, if you observe here is, this is the workpiece, sorry, this is the die, the blue colored structure. This is the workpiece here, you can see here, and there is some explosive material which you can see here, this colored structure. This is loaded within a cartridge. Now here the explosive material placing in this cartridge, it is taken to the point where you can see there is some cavity of this die. At this position, this particular explosive material is placed and it is exploded. Once it is exploded, you can see here at the side part, whatever the design of the cavity is there, it is developed with the help of the forming process. So this we call it as explosive forming using contact method or a confined method, where the explosive material comes directly in contact with the workpiece material, and once it is exploding, it is resulting to deform the workpiece with respect to the die cavity design. So almost, if you see here also, we are having some of the advantages. One very much advantages along with the aerospace industries, you can use even in the production of some automotive related components also. And the process has the greatest potential in limited production prototype forming. Prototype forming in the sense, many times before we go for the designing of any component, we need to know a prototype model. So once we have a prototype model, depending upon that, you can manufacture large number of products within less amount of time. And when compared to a Standoff Technique, it has a low production cost. Low production cost in a sense, don't need to design a large cavity. There is no need of a vacuum pump. Water is not required, which means the cost of this one is very much cheaper when compared to Standoff Technique. But what are the disadvantages? The first disadvantage, if you observe, when we are using contact method, sometimes the pressure whatever is built due to detonation, if it is so much high that it may lead to the damage of the die failure also, because here the explosive material comes directly in contact with the workpiece. Here also vacuum is essential, but many times if you don't check for this one, it may lead to the damage of the surface finish of the workpiece. Air present in the workpiece is compressed, leading to heating, yes, and not suitable for large and thick plates. Generally, we are using this method for the bulging of the tubes or flattening of the tubes. We are using this method, so we cannot go for deformation of large and thick plates. Second type of forming process is electro-hydraulic forming. So if you observe carefully in this sketch, even the electro-hydraulic forming, it is as similar to the setup. This particular part, if you observe, it is similar to that of an explosive forming itself. Only the difference is here, instead of explosion, we are having two electrodes to which an wire is being connected, and these are connected to a capacitor banks with some power supply, and a resistor is used. So here in this electrohydraulic forming process, the energy is developed when the circuit is closed, and the capacitors are able to develop sufficient of element of energy through these electrodes by developing a spark at these ends. The spark developed is so much high that it is developing more amount of energy, which is sufficient enough to deform the workpiece with respect to the die cavity as designed in the shape. So in very simple words, what you can say that only the type of energy generation is different when compared to the explosive forming. Here we don't use explosion. Instead of that, we are using the electrodes, which are being charged with the help of a capacitor. Once they are in contact, they develop a spark to develop high amount of energy, which is responsible for deforming this entire workpiece. So you can see here there is a capacitor bank, charging resistor, discharge switch. So once the circuit is in under process, that is once it is in closed condition, between these two electrodes a spark is developed, and due to that spark the energy is developed is so much high that when it passes through this water medium, it is deforming this present workpiece to get a desired dome shaped material. So it is also having some advantages. What are the advantages if you observe when compared to this one? Better control of the pressure. Yes, why the better control of the pressure is when once the explosion is done. When the previous cases, you don't know how much amount of energy is generated, but here when it is taken from the electric source, that is the capacitors, depending upon the pressure pulse developed inside the water, you can judge whether to increase the source of energy or decrease the source of energy, which means you can easily control the electricity. When compared to the explosive materials, it is safer in nature. And if you can develop very small and medium sized materials, you can use this particular method for deformation. You can prefer the thin metals, which can be deformed in a smaller with less amount of energy. Also, you can use for the other methods also. But some of the limitations is This is possible only when the workpiece sizes are smaller in nature, which means smaller workpieces you should need for vacuum to become the more complicated device. And here also you should know what is the standoff distance necessary for effective process. So if you observe, even the spark which is developed here, it is developed at some distance away from the cavity plate itself, which means the standoff distance you should know particularly for this kind of material also. So applications, if you observe, generally we are including where for developing a radar dish, cone and other shaped and thinner small workpiece materials. Then the last type is electromagnetic forming. This is a method generally where we are using is especially for fastening the metal parts or for some swagging purposes also. So if you observe here, this is there are two workpieces if you observe here, and here is some die cavity. So if I want to bulge the tube, if I want this workpiece to bulge in the form of a tube structure, it is not possible using the other three methods, but with the help of this magnetic field developed, we can develop this very easily here. So here what we are doing is, in the previous case for the electro-hydraulic forming, I told that with the help of electric energy developed, we are going the pressure pulse for the deformation. But here we are taking the help of an magnetic field developed. The help of a magnetic field developed, which is responsible for deforming the workpiece material. So let us see how it is happening here. So if you observe here, there is a tube around which the coils are being unit, that is the capacitor coils. And these capacitor coils, they are charged initially with the help of electricity. Now, if you observe, there are two workpieces. This is one workpiece. This is another workpiece. And there is some a die cavity present. I want this workpiece to take the shape of this die cavity. So what I do here is, I place this capacitor coil along with these coils over this workpiece. And once the current is being discharged, the energy is being discharged, then if you observe here, there is a magnetic field developed within these coils itself. So these are the coil currents, this is the eddy current. So what happens, there is a magnetic field developed between these coils, and the energy developed is so much high that here between these the repulsion forces are developed. Due to this repulsion forces, this part of the material, if you see this part of the material, it goes for deformation and attains this curved shaped structure. So automatically when this attaining the curved shaped structure, this is due to the magnetic field developed between the eddy current coils itself, which is sufficient enough to deform the present workpiece in the form of a bulging of a tube or a ring like structure also. So advantage, if you observe here, generally we are using for the small tubes. Sometimes for the bending we are using, collapsing we are using. And here also when we are taking the help of magnetic field, you should know how much amount of electrical energy is required for which kind of deformation of material. Depending upon that, we can take current depending upon the intensity required for deformation. When compared to electric hydraulic forming, again this process is safer. Even compared to the explosive forming also, it can be used for a wide range of applications, especially for smaller kind of materials, that is for fastening, screws and other devices also. Limitations, especially you have to use this one only if there are conducting materials, that is the materials, if they are made up of material, aluminum or copper, we can prefer this method. For other materials, it is not so effective. You cannot go for deformation of large workpieces, only small workpieces you can deformation. And before it, the important thing is you should see that there should be a clamping done perfectly with the primary coil itself. Otherwise, the effective magnetic field cannot be developed, especially in this type of electromagnetic forming process. And the shorter life of the coil due to large this is once the energy is once the coil is being charged with the electricity, it is having certain amount of time till the energy is being discharged. So you should see that depending upon the thickness of the material, the coils have to be chosen to see that they are charged with the help of electricity. And once they are discharging the energy through their magnetic field. The deformation can be carried effectively. This is the things. So these are the things related to the explosive as well as HERF processes. Thank you, students.